Welcome everyone, I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 1942, which is the number of the smallest unoccupied chair. Let's see the problem statement. There is a party where n friends numbered from 0 to n minus 1 are attending. There is an infinite number of chairs in the party that are numbered from 0 to infinity. When a friend arrives at the party, they sit on the unoccupied chair with the smallest number. For example, if chairs are 0, 1, and 5 are occupied, when a friend comes, they will sit on a chair number 2. When a friend leaves the party, their chair becomes unoccupied at the moment they leave. If another friend arrives at the same moment, they can sit in the chair. You are given 0 index 2D integer array, which is times, where each of the element of times will be arrival and leaving time, indicating the arrival and leaving times of ith friend respectively, and an integer target friend. All arrival times are distinct. Return the chair number that the friend numbered target friend will sit on. Let's see an example. For example, times array is this and the target friend is 1. 1, it is the target friend will be 0 index, like it will be the index of the given order of times. Okay, 1 means this is the friend we need, which is who is coming at time 2 and leaving at time 3. So for the first friend, like friend 0 arrives at times 1 and sit on the chair 1. Friend 1 arrives at time 2, so he will sit on the chair 1. So we need to return 1 because of this. We do not need to check the other friends also, because if the friend number 1 is sitting on chair 1, we can directly return the answer. Okay. Let's see the constants. The n will be up to 2 to 10 to the power 4, and each of the element of times will be length of 2, which is arrival and leaving time, and the arrival and the target friend will be from 0 to n minus 1, and arrival and leaving time will be up to 20 to the power 5, and each of the arrival time is distinct. Okay, so you can solve the problem using priority queue. You need the min heap, because each time you need to assign the smallest number chair to a friend. So you can use that. I will use set to solve this problem. So first we need to the minimum number of chair required to seat all the friends. So let's say in worst case we need n chairs to in n chairs to which we will assign each chair to each of the friend who is coming. So in worst case there will be n number of chairs. So let's make it. So set into will be the data type. Let's say st. It will require the min number chair. It will give the min number chair. Okay, next we also need another set to check all the like arrival times and leaving times. Like for each of the elements of times we need the we need to sort the arrival times and leaving, because they might be like discrete, like for 3 is coming before, 1 is coming after. We need a sorted order, so we will use another set for that. So vector int, and to sort them we will use custom sort function. So we will create that. So comparator, let's say the name is tst means time or time set. So it will give us the sorted ordered time. Okay, next we need to add all the elements, or like elements means the arrival times in our tst. So for int I equal to 0, I less than times dot size I plus plus, and we need also the number of chairs. The number of chairs will be up to n in most case, so we will add all the number chairs. Let's say st dot insert I will be inserted each time, because in most case we need 0 to n minus 1 number chairs, and tst dot insert we will insert the arrival times only this time, and after that we also need to add the living time along with the number chair. So first we will add times of I. The arrival time is the first element, which is 0, along with the living time, which is times I1, and the index like I, because we need that index to compare it with the target friend, because the target friend will be given like the order of the given time, but when we will sort the elements of time, then the order will be changed. So we need the index value to check it with the target friend. Okay, that's it. Now while tst.size exists, which means at least there is an element in t.size, first we will pop it out the first element. So the first element will be vector int, let's say temp is equal to star tst.begin. Tst.begin will give us the reference and we need the value. So we need to dereference it. So put a star before it. Now we need to erase that also, because we do not need it again for the next iteration. So tst dot erase tst dot begin. That's it. Now we need to check if first let's make it the comparator function, then you can understand what is the difference between the arrival times and the like living times, because for arrival times in our vector in set we need three like elements: the starting time, ending time, and the index. But for living times we do not need three elements, we just need two elements, which is the ending times and the that chair number which it was occupied. Okay, so we just need two elements. So let's make the comparator function. So use struct comparator. So to make the comparator function, we will use boolean. The return type will be boolean operator, and it will take two parameters. So first one is const vector int. Let's take the reference a, and const vector int b. Return type will be const this. So we need to sort the given like we need to sort the time st with the arrival times, sorted as sort in ascending order with respect to the arrival time. So first we need to check if the arrival time is the first element. So if a of 0 is less than b of 0, then that which means a's arrival time is lesser than b, so we need to return true. Return true means A will comes before B in the sorted container, and the other condition is if A0 is greater than B, we need to return false. Next, if both are equal, you can see the problem statement. If both are equal, we need to keep the like living time before the arrival time. So to check that, we will check if A dot size is not equal to B dot size, then we need to return a dot size is less than b dot size or not, because for living time there will be two elements, so size will be 2, and if it is a arrival time then there will be three elements, so size is 3, and we need to keep the like living time before the arrival time. So we will check if a dot size is 2 and b dot size is 3, that means a is living time, b is arrival time, so it will return true, which means a will come before b, and otherwise else If a dot size is equal to b dot size, then it doesn't matter what comes before, because both are coming same time, and both are leaving, and or both are incoming. So like both are arrival or both are leaving. So it doesn't matter. You return true or false. So just return anything like true or false. That's it. So our comparator function done. Now here in if condition we will check if temp dot size is equal to 3 or not. If it is 3, that means it is a arrival time, and else it will be a like leaving time. So for arrival time we will have three elements. So int start will be temp 0, I'm copy pasting it. End will be temp 1, and the index will be temp 2. And we also need the chain number. So the chain number, let's say ch, will be the first element which comes in st. So to get the star st dot begin, it will give us the sorted number chair. Okay, and we, as we are giving this chair to this friend, so we also erase that chair from our set. So st dot erase st dot begin. That's it. Now we need to check if this current friend is the target friend or not. To check that, we will check that with index. So if ind is equal to target friend, that means we need to return the chain number, which is ch. Otherwise, we need to add this current friend with the end and chain number, because this friend is living at time end, and it is occupied ch. So after this end time, the ch number chair will be vacant or unoccupied. So let's add it to the time set dot insert the end time along with the ch, the chair number. That's it. And else condition, that means the current friend or the current element is a living time. So for living time we will have end, which will be temp 0, and end ch, which will be temp 1. That's it. And as it is living time, so we do not need to check anything, we just need to add this ch number chair to our st. So st dot insert the ch number chair. Okay, that's it. Now after this while loop, we already have returned the ch number chairs, as the target friend will be from 0 to n minus 1. But as we need to return anything something from this function, so just return -1 or whatever you want, because the control will not come to this line, because we already have returned the answer. So let's see will it work or not. It is accepted. Let's submit it. So it is accepted. Let me discuss the time and space complexities of this algorithm. So this first for loop is running n times, where n is the length of times. And for each element times, like for each iteration, we are inserting one element to st, which will take big of log n time, and we are also inserting one element to the t of st, which will also take big of log n time. So overall time complexity for this whole for loop will be big of n log n time. Now for this while loop is running till it, at least one element is present in TST, and the TST can contain at most 2 into n number of elements, because for each of the element present in times there will be one arrival element for an leaving element. So both will be added to TST. So in worst case there will be at most 2 into n number of elements in t dot side. So it is running 2 into n number of times, and for each of the iteration we are erasing one, and begin for accessing the begin it will take big of one time, and for erasing it will take big of log n time. And here is also we are inserting, so overall every insert or erase it will take log n time, big of log n time. and for begin it will take like big of one time. So overall for each iteration overall time complexity is big of log n time, and we are doing it for 2 into n number of times. So overall time complexity for this whole while loop is big of 2 into n into log n time. You can exclude the 2, so you can say the whole time complexity for this while loop is big of n log n time, and this for loop is also taking big of n log n time. So overall time complexity is big of n log n time. And for space complexity, this set is taking at most there will be n number of chairs, so it is taking big of n space complexity. And this TST I already told you, it at most there will be 2 into n number of elements. So the space complexity for this TST is big of 2 into n, or you can say big of n. So overall space complexity for this whole algorithm will be big of n. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.